So now we are into the respiratory zone. So the terminal bronchiole would be the last part of the conducting zone, leading to the alveolar duct and the alveoli at the end. The alveoli surface area is approximately equal to a tennis court. So lots of surface area. In this animation, you can see air going into the lungs, which causes the alveoli to inflate, and then they'll deflate as air is pushed out of the lungs. As we mentioned before, pulmonary ventilation is breathing. It is a mechanical process that's dependent on pressure and volume. It's controlled by the diaphragm, and there are two phases of pulmonary ventilation. So one of the phases is inspiration. This is breathing in. Inspiration is the result of muscle contraction. When the diaphragm contracts, it flattens. And when the external intercostals contract, it raises and expands the rib cage. This causes changes in the thoracic cavity. The volume increases because of those contractions, and it also decreases the pressure. Because of that, air passively rushes into the lungs, stretching the lungs as the alveoli inflate. Expiration or exhaling is the opposite process. Expiration results from muscle relaxation. As the diaphragm relaxes, it raises up and returns to the dome shape. And as the external intercostals relax, it causes the rib cage to lower. This too causes changes in the thoracic cavity. The volume decreases and the pressure increases. And that pressure forces air out of the lungs. The alveoli deflate as the lungs recoil. You can feel some of those changes occur if you take a deep breath in and then you exhale. When you take that breath in, you can feel your rib cage coming up and outward, which is increasing the volume of your thoracic cavity. And when you exhale, you can feel how your rib cage actually falls, reducing the volume of the thoracic cavity. So this is just a comparison of what happens in inspiration and expiration. This is a video showing healthy human lungs being inflated. Dead space is referring to parts of the respiratory system that's not being involved in gas exchange. So total dead space is actually a sum of anatomical dead space and alveolar dead space. Anatomical dead space is air that's trapped in the conducting respiratory passages. So think of inhaling. Some of that air is reaching all the way and inflating those alveoli, but there's going to be some air that hasn't made it all the way there that is trapped within the bronchi, the trachea. That would be anatomical dead space. Alveolar dead space refers to alveoli that are no longer functioning because they've collapsed or they're obstructed. So the total dead space is a combination of both. The anatomical dead space, where air is just trapped in passageways, as well as alveolar dead space, where we've got alveoli that aren't able to function.